Though this webinar has been given the title Database Design for MySQL, whether you design for MySQL or MS SQL or Oracle or DB2, they are extremely similar. I would say almost 99% will be same with each design, because database design is pretty common irrespective of the database that we use. Just before going to the database concept, any application that we use will have input coming from graphical user interface. Then the data input always comes from GUI. Data is processed by programs, okay? Some business logic is applied. Then data is stored mostly on the DB. So from the screen, the data comes. It is being processed for various business rules. Then finally, it is stored in the database. How it gets displayed onto the UI is a UI design. There's a separate way to do the UI design. Data is processed by the programs. How to process? That's a program logic. Storing the data, that is the database design. What we are going to cover is this portion. How to store data into the database. That is what is called database design. Okay. DB design. If you take product design, right? The SDLC contains requirements phase, design phase, coding phase, then testing phase. Within that, the design phase, this includes GUI design, it includes DB design, this includes interface designs. At the same time, it includes logic design also. In one of our previous webinars that ended last week, we talked about GUI design, interface design, and logic design. This session is exclusively for DB design because ultimately, since this field is called information technology, database is the key. Irrespective of the programs do, work, run, finally data has to be saved somewhere. And if database is central, okay, that means it is located in a single place and that is shared, many applications can use that. For example, within the organization, there may be multiple applications that can be using the same database. So if database is clear, accurate, then almost half of our headache is removed. And since the data is vital to the business, right? There is a field called business intelligence, okay? Business intelligence is nothing but get meaningful reports out of data so that the management can take decisions and that can help the business to grow. But to get the business intelligence and get data in a presentable manner, first of all we should have data, right? That is what we are going to look in this webinar, database design. Quickly talk about purpose of database is store data. Whatever business information, store it, retrieve it. So once I store, I want to get from the screen, present it in one manner, right? Search the data, sort data, right? update and delete data. This is what the purpose of the database. Any database, if you see, I want to store, I want to get back at a later point of time. Within the data, search if this is present or not. Sort the data, give me some reports, okay? Sort it in the descending order of the cutoff marks for the engineering examinations or IIT examination. Show me the top 2000 ranks. That's sorting. Update the data and delete the data if it is not required. So this is the purpose of database that everybody, I'm sure, is aware of that. But how to do the design? Database design is not again rocket science, but it has to be done meticulously. Okay. Once you do the database design in a careful manner, after that, all these operations, right? Retrieving, searching, sorting, updating, deleting will be much more easy and comfortable for you. If the database design is wrong, then obviously it will hit the performance. One of the major issues applications may face, okay, if database design is not correct, if database design is bad, the performance will be very slow. That can happen. Second major issue, right? Data accuracy. Imagine a bank says the balance in your account is only 99.5% accurate. Will you accept that? We cannot. If database design is done wrong, it may lead to data accuracy and I would say integrity, because unless the data is having full integrity, we cannot trust the data. It will lead to doubts, which will spoil the fame of the application. Systems can be running, it can be shut down, but data must be persistent. It has to be on the disk. If anything that happens on data, then customers will cry at you, yell at you, shout at you. So the two major issues that you may face because of a bad database design is performance and data integrity. With that precursor, shall we proceed to the next level in the database design? Is this clear? The purpose of database, issues coming to database design. Good. Okay. Now, as I said in the previous webinar also, when it comes to design, first understand the specs. The specs or the specifications or the requirements. You should be very, very clear. You cannot leave a single point out of the design, right? Of the specs, sorry. Only when you have a good grip on the specs, you can have a good grip on the design. This we have stressed in the previous webinar also, that covered product design, class design, method design, UI design. So understanding the specs is the key. For this webinar, I'm going to take an example. Example of cricket match statistics system. You might be hearing running commentary on the radio or TV. Suddenly a statistician will pull the data. This particular batsman has scored 1000 runs against this country away from the home ground. Suddenly he pulls out a statistics. Suddenly for another ball he will say this particular bowler has always got a wicket when he bowls a googly, especially for the batsmen who are in the rank of 6 to 11 within the batting order. How does he get that information? Because ball by ball, run by run, shot by shot, everything has been put into the database. From the database, people retrieve information the way they want. So, in a fraction of a second, the statistician is able to pull, right? Able to pull data in whatever form needed. But for that, the important aspect is, first of all, I should have the data inside. If I do not have the data inside, then obviously I cannot pull data out of it. How to store the data? That is what we are going to see. Let us first discuss the specification of the cricket match statistics system. I will outline what I need from the system. Okay. Features I need from the system. Okay. Number one, or let me say just every match must be tracked. Okay. This is one of the requirement. Every single match must be tracked. That includes 5 days, 1 days, 2020s. Every single match must be tracked. Now, every national level matches must be tracked. That means in India you play Ranji Trophy, Duleep Trophy, which are national level. Same way in UK they will play county matches, right? There are some international matches, there are some national level matches. This system will track national, I would say every international level match must also be tracked. Every ball must be tracked. Every shot must be tracked. Every run must be tracked. Every decision must be tracked. Okay. And details about commentators to be tracked. When I say from 3 o'clock to 3:30, person A and person B were giving commentary in that particular language. From 3:30 to 4 o'clock on this particular day, person X and Y were giving commentary on a different language. Okay, that information we need. All details on umpires must be tracked. That means for the 15th over, who was the leg umpire, who was the primary umpire, right? I need to know that. And whether the ball is bowled from the pavilion end or from the far end. What is the speed of the ball? And what is the length at which it pitched, right? Whether it was an offside ball or a middle ball or a leg side ball. Ball by ball we need to track every shot, whether it's an offside shot, leg side shot, right? Whether it's a lofted shot, whether it was a drive, whether it's a glance. So if I track all these information, okay, if this is tracked, then I can say 45th over in a match between two countries on last September, the third ball was bowled by this person at this speed and it pitched at this point. I can get the data accurately. Then I can say this particular batsman has always scored at least a single run in every reverse sweep, right? When I say every shot must be tracked, what is the type of the shot? Is it a cover drive? Is it a glance? Is it a late cut? Is it a square cut, right? Is it a straight drive? Everything should be tracked. Why do I need this? First of all, why do I need this? The purpose of this is provide accurate statistics on any ball bowled. This is my vision. To get this information, we need to have a huge database. There are hundreds of matches played every year, balls bowled, information is fed and I want to get this information. Is this clear to you all? Is the functionality or the specifications that I drafted out, is it clear to you all? Can you please raise hands if so? Any doubts in this? If you have any doubts in this, please raise now. Because before going to the design part, I would like to knock off all the questions right here. Any questions? Okay, one person has asked, what about the altitude of the ball? Okay, yes. Let me say ball must be tracked. This include altitude also, right? Full toss or whatever. There is another person who has given, it's a very good detail, right? Environment like wind speed to be tracked. To be tracked, environment, wind speed, humidity, temperature, everything to be tracked. Okay, then, wow, another person. Fielding positions to be tracked. Okay, let us make it complicated. Okay, that means for this ball, player X was standing at silly point. Yes, we want to track that. Then power play details. Okay, power play details to be tracked. Then so environment with respect to wind speed, light, humidity, temperature to be tracked, power play details to be tracked, fielding positions to be tracked, right? So scorecard is a run, so run details are also tracked. Then what else? What else do you think? Okay. Yep. Another information along with the environment, one person has suggested pitch details. Okay. Pitch details to be tracked. Good. Yeah. At what time the pitch has been given a roller treatment, right? Whether it's a light roller or a heavy roller, right? That needs to be tracked. Same way like off the field, right? The off field, whether it is wet, what is the mist conditions to be tracked. Good. Now, to make this into a database, what I need to do that? Step 1. The step 1 that you are going to look here is identify top level data items. Okay, don't go to the micro level, go to the macro level. Macro or top level data items. This is step 1. Right? What are the data that we want to store? Okay, I want to store about match, right? I want to store some details about match. Okay. I want to store some detail about umpires. I want to store some details about pitch. Then I want to store details about overs, batsmen, fielding, right? Fielding or fielding positions, let me say. Then runs, right? What other macro level detail that you are storing, right? Strokes or shots. Okay, let us say shots. So I want to store about these details. Okay, then there is something called power play also. So what type of, wherever you are seeing something, I want to track this, I want to track this, those are all the macro level data elements. Okay, that's the step 1. Okay, Now, the next step. The first step is identify the top level or the macro level data items. The second level, take each of these data items. Number 2, identify micro level data elements. Take match. For match, what are the data that you want to store? Okay, that's the second thing. The second part that you want to show is match. This is a slightly difficult part. Okay, let us see a few examples, then probably you can determine that portion easily for other macro level data. For a match, I want to say which country, which is country A, which is country B that play the match. Or I would simply say team A, team B. Who are all the players? Who are all the teams that play? Second thing, type of the match. Okay, type of the match, whether it is 5-day or 1-day or T20. Then I want to know date, from date it is played, to date it is played, right? Then day or day night match, that information, it's a day match or a day night match that is played. Then stadium at which it is played, right? Any other details that you think for a match is required? Yeah, the stadium is the venue. I can always say country in which the match is played and then the city in which the match is played, right? Even if the stadium name is same, because we can have Sir Vivian Richards stadium in different countries, right? For each match, I may want to have a unique match number. Okay. Now, this is at the match level. Now, same way, you can talk about umpires. I want to maintain a list of umpires. Okay. So you want to have a first name, middle name, right? Last name, right? What else you want to know about the umpire, right? Right? Which is the country to which they belong to, right? Then okay, this is fine to start with. Then we can, of course, we can always, okay, date of birth of the umpire, fine, that's okay. Then grade of the umpire, right? Whether he is supposed to be the international level umpire or I would say national level umpire, right? That's one. Good. Now, let us take about player. For a player, what details you want? Again, I could say the same information that can come over here, right? Whether it is an ICC grade or whatever. Type of the batsman, type of the player. That's a player, is a batsman or a bowler or an all-rounder, right? Right. Now, this is one good question has come from one of the audience is number of runs scored by a player. Okay. When I say number of runs scored by a player, here you need to understand one point. Certain data are primitive or also fundamental. Okay. Certain other data are derived. For example, if I store all the scores of a particular batsman, by adding all those individual score, I can get the total score. Here, the number of runs scored by a single batsman on a particular match is a primitive data or fundamental data. Total runs scored by a batsman against that country is a derived data, right? So if you store primitive data or the fundamental data, derived data can be obtained by retrieval process in the database. You don't have to store the derived data also. If you are able to store the primitive data or the fundamental data, database will help you to retrieve the derived data. So total number of overs bowled by this person, total number of balls bowled by this person, total number of runs scored by this person, total number of sixes by a person, they are all derived data, right? If you know at which over or which ball this person has scored a 6 individually, then you can club all those things, arrive at the derived data. Now, let us talk about over. What data you want to store about the over? Again, we talked about each match is a, right, match number, in which match the over is played, then over number, and then within the match you always have also innings number, right? Whether it's the first innings or the second innings, then bowler name, pavilion or far end from which the ball has been bowled, right? This is the over. Primary umpire for this over, leg umpire for this over, right? Then what else you want to, these are all primitive data. How many runs are scored in this over? We can get it from a different set of data, but as an over, to identify over individually, you can always, if you are given this information, can you find out? Okay. Same way for the fielding positions. Okay, let me take a macro level data. Fielding position. For this, you type what are the fundamental data. You type it and then send it to me through chat. To store the fielding positions, what information you want? Okay, of course, match number, over number, that is correct. Then ball number, correct. Okay, because ball by ball, the position can change. Okay. Then there are two things that I need. Number one, position, silly point, long on, long off, right? Mid on, mid off. So position over the field. Then player name or the fielder name. Okay, I can say long on is Sachin Tendulkar, wicket keeping by Dhoni, right? We can put that information, right? I don't have to say player at long on, player at long off. You need not have so many fields, but in Excel sheet, I can always have a pair of information, right? At long on, we have Sachin. At mid wicket, we have Sehwag. At point, we have got Harbhajan, right? If you store these pairs, right, the position and the player name, deep fine leg, comma the player name, fine leg, comma the player name, right? So if you know this pair, by having this information, ball by ball, we can store this information, right? Good. Good going. Now you tell me about charts. What primitive data within charts you want to store? Everywhere hereafter you will see, to identify a chart, I need to have in which match, in which over, in which ball the shot has been played, right? That information I need to store. Otherwise, I cannot have very clear identification. Shots, okay, player name. Who is the player who faced the ball? Then, who did the shot, right? Then, type of the shot, whether it is a loft, whether it's a glance, whether it's a, right? Then, what is that? Good. Runs scored. Runs scored. Then, what else we need? Okay. Yes, one other person has suggested length of the ball traveled over air, because, or I would say, how to name it, maybe the clearance, right? They will say this person has hit a 6 which is 90 yards, right, or 94 yards, right? They will actually store that information also for every shot, because you could see the wagon wheel that could show where the ball landed, right? So you could see some balls landing at half the ground, some balls landing beyond the boundary line. So that, what is the length for which the ball traveled over the air after the shot, that is also calculated, that is also stored. So for every shot we store this information. What else? Good. Now, is this clear to you, this exercise? Just two simple rules. Number one, identify the macro level data. Number two, for each macro level data, identify micro level data. Is this clear? Now, as an exercise, can you people prepare for the other things, right? I have talked about shots, batsmen, but for over also we have done it, right? Ball by ball details, okay? Ball details, every single ball details, what are the elements, micro level elements you need, okay? Then for power play and pitch information, for these three, ball, power play and pitch information, of course environment, okay? For these four elements, can you people take it as an exercise? Prepare data, okay? And then send it to me, or say send it to webinar@softsmith.com as an exercise. Will that help? Can you send this information to webinar@softsmith.com? You prepare data for these information, ball details, power play, pitch, environment. The environment may include wind speed, it may include temperature, it may include humidity, right? Off-field status, right? Can you get that information? Okay, good. Any doubts in this? Because this exercise is going to be, okay, one person has asked, what are primitive data? What is a derived data? Anything that identifies a unique value, right? I would say a specific value or a specific information, that's a primitive data. anything that you get as an inference, right? For example, how many test centuries Tendulkar has scored? The moment I say how many, unless I know against which countries on which match Tendulkar has scored 100, if I know those lists, then only I can count 1, 2, 3, 4, 5, something like that, and then say, okay, now he has scored these many centuries. Without that base information, I cannot get the count. Anything with respect to count, average, right? In simple terms, right? Count, average, minimum, maximum, right? Sum, all these things are applied based on some base data. That base data is called primitive, right? Yes. And then anything that you get as an inference, that is called a derived. So if I say a mark sheet, marks for individual subject are primitive. Total marks or average marks or engineering aggregate is a derived one. Okay, we have given very specifically 5 days to this webinar because we want to go slow, because one thing that we found out in most of the projects where we consulting as well as within our company, a deep understanding about the database always helps the person to do better development and better testing. Most of the confusion comes when they don't understand the data. If we are able to make them understand the database design and the underlying data, we could see amazing amount of productivity increase from every single person. Okay, so that is why we are taking time to spend these 5 days to tell point by point of all the things. And usually we take only for first 40 minutes we take the webinar, then we are open to questions. You come up with questions, we are ready to answer. Now the time starts for you to ask questions within the portion today that you have taken. Okay, and one more thing is, again, we don't have to send the notepad to you people, but this whole webinar is getting recorded. If you go to the Open Mentor portal, you could see information is being available as course demos. Within that, you can see a recorded webinars. Many webinars are being uploaded as the entire session is recorded and then sent. So you can view right from there. But we will take some time to edit and then upload into our website. Okay, any other question? Okay, one person has asked another question saying that, will you be talking about syntax in MySQL? Last we will see the create table syntax, but to create the tables you need to have the database design ready with you. So we will take you up to design the tables, then from that how to create the tables physically on MySQL using create commands. To that extent we will go, but we will not go to select, insert, update, delete commands into the database. Another question has, it's rather not a question, it's more of a suggestion. Yes, probably from tomorrow we will use Excel sheet, okay, because Excel sheet itself will have rows and columns, so that will be easy for us to do the database design. Yes, we will use Excel sheet. That. One person has asked a question, will you be talking about ER diagrams and relationship diagrams in database? We will use some of the concepts like primary key and foreign key, okay? This will be more of conceptual, okay? Because design is a concept. We don't want to restrict ourselves to a specific tool, but things like primary key, right? Foreign key, then talked about a unique index. These things we will talk about. along with the design. Towards the end, once we have some amount of databases designed, the tables designed, there is a process called normalization. Okay, this normalization will come at a later part. Okay, because once you have got a clear understanding of the tables, then only the normalization comes, right? Okay, we will talk about that later. Okay, another question came in terms of, do we have a separate design for Oracle, MS SQL, MySQL? I think probably this person might have joined a little bit late. As I said earlier, DB design is common. It is irrespective of the individual syntax of a particular database system like Oracle or MS SQL or DB2. Design is common. So if you know how to design, then it is up to you to create the scripts using create statements in that particular syntax. So it is not different for different databases. In the subsequent classes, we will be talking about, today we just identified the data, right? Today, it is only identifying data and grouping of data, okay? We did macro level and micro level, but there are something like attributes of a data, right? Then logical grouping of data, right? What we see here is a grouping of data based on our need, right? But should that be in this table or should that be in the other table? So that is called a logical grouping of data. Then of course normalization, right? And then creating data samples. To ensure that we are on the right track, we need to create data samples. Those things will be dealt in the subsequent classes. Right? Of course, when we talk about the logical grouping, this is where we will be talking about the relationship. Okay, relationships like one-to-one relationship, one-to-many relationship, many-to-many relationships. Right? That is what will come in the logical groupings. Are we going to talk about data type and size? Yes, that is what is called attributes. We will be talking about data types and sizes in the next class. That comes under data attributes. What are the databases that are currently in use? That's another question. You can say Microsoft SQL Server. That is a database. Oracle is a database. MySQL is a database. DB2 is also used a lot in IBM mainframes, right? There is something called HP non-stop SQL, right? There is a Progress database. There are a lot of databases available, okay? Is there any other question with respect to today's portion? Okay, in this session we are not going to concentrate on SQL queries because that will be a separate session of how to use MySQL. Okay, join, select, those things are not part of this. This is purely design. Okay, this is not usage. This is purely a design webinar. So we will meet tomorrow. We will continue with data attributes, logical grouping of data and the relationships, and continue from there. Thanks for joining. We'll meet tomorrow.